Hello dear classmates. We are talking about finding the volume and curved surface area of frustums today. Now note that this is just a general idea of how we can easily find the volume and surface areas of frustums instead of giving you a formula that you need to memorize. So now, let's start the topic. Of course, I suppose that all of us already know about what a frustum is, and therefore I won't intend to spend the time to find the definition for frustums. And therefore, well, for example here, in this frustum, we're given with the height of the original cone is hcm, and therefore, let's label this one, the original height, as hcm. And then, we are given with the radius of the original cone, that is, the base radius here, is rcm. Base radius is rcm. And finally, we're given with the height of the frustum is hcm. So this length or this height is hcm. And then, with these, we are required to find the volume of the frustum. Okay, so we have to find the volume of this section, the volume, right? Not the area yet, but also we need to find the curved surface area of the frustum, just the curved surface area, not include the top of the base. And so let's study our strategy of finding these information. So our strategy would be, we need to find the volume and curved surface area of, now we do it at the same time, volume and curved surface area of the original cone and then the cutaway cone, the top part, okay? The difference, of course, would mean the volume and curved surface area of the frustum. So here it is, the strategy. So now, let's start. So our first step is to find the, okay, let's cover these up first. Our first strategy would therefore be, let's find the volume and curved surface area of the original cone. Now, for the original volume, okay, let's write the short form, volume of original cone. Now there is no need to think too deep because we can apply the formula. Volume of a cone is the base area. Now the base area of the original cone is pi r squared, and then times the height of the original cone, which is capital letter H, and finally divide this volume by 3. So divide this volume by 3, then we get the volume of the original cone. Let's give it some unit 2, it's cm cubed. And then curved surface area of the original cone. Well, we simply use a formula again, right, which is pi r L. I suppose all of us remember. So pi, r is the base radius, and L is the slant height of the original cone. The slant height is square root r squared plus h squared using Pythagoras theorem. So this is cm squared. Now next, we find the volume and curved curved surface area of the cutaway cone. Now note that we don't have to use very difficult method, such as finding the radius of the cutaway cone. We apply the knowledge of ratios all at once. That is, we find the ratio, the length ratio of original cone. No, we find the cutaway cone first. So length ratio of cutaway cone to original cone. it's obvious that the length ratio is big H minus small h to the big H. This is the cutaway cone's height to the original cone's height. Therefore, the area node, we find volume first. So volume ratios of cutaway cone to original cone. Just cube the above length ratio. And therefore, well, the volume of the cutaway cone was simply equals to the volume of the original cone times the ratio. So what is the ratio? The ratio is h minus h to the power 3. Oh, maybe I should write a smaller bracket. Okay, sorry, smaller bracket. H minus h to the power 3 over h to the power 3. Okay, we can simplify this a little bit, which is equals to 1 over 3 pi. Now r cube, no cancellation. Sorry, not r cube, r square. R square, no cancellation. H is cancelled with the denominators h by 1s. And so we have r square over h square times h minus h to the power 3. Now, this is, oh, by the way, is cm cube. And therefore, volume of Frustum would be the difference of the cutaway cone and the original cone. The original cone, 1 over 3 pi r square h. And then minus 1 over 3 pi r square h minus h to the power 3 over h square. Well, in fact, there's one simple method. In fact, it would be taking out the 1 over 3 pi r square h out. You can see that this is simply 1 minus the ratio of the volumes, which is h minus h to the power 3 over h to the power 3. Somehow, there's no need at all to find the volume of the cutaway cone. Some students can simply apply this difference of the ratios. Now, let's simplify this fraction. Simplifying the fraction, 1 over 3 pi r square h. Or we will come at the denominator of h cubed. And that will be h square minus, sorry, not h square, h cubed minus h minus h cubed, which is equal to 1 over 3 pi. Well, let's cancel one of the h. Okay, and h cubed minus bracket h minus h cubed. We'll expand this one, h cubed minus h cubed plus 3h square h minus 3h square plus h cubed. So this would equals, what's wrong? So this would equals 1 over 3 pi r square. Well, let's simplify this ratio. Right, h cubed minus h cubed is gone. We're only left with 3h square h minus 3h square plus h cubed. Well, we can leave the result like this, just at the unit spec, and this would be perfect. Now, next, if we want to find the curved surface area of the Frustum, we can repeat almost the same thing. There's no need to do everything all over again, just like before. We will have the length ratio of the cutaway cone to the original cone, still h minus h to h. And therefore the area ratio of the cutaway cone to the original cone will equals to, well, this time instead of cubic that, we square that. And therefore curved surface area of the cutaway cone will equals to, well, the original curved surface area is pi r l. We multiply this one with the ratio h minus h square over big H square. And therefore, the curved surface area of the frustum will equals to, well, the original curved surface area pi r l minus the answer above, and therefore we can take out the common factor. Of course, we can common the denominator, and therefore this becomes h square minus bracket h minus h all square. This would equals to pi r times square root r square plus h square. And then let's do some simplification. H square minus h square plus 2hh minus small h square divided by h square. So it is pi r square root r square plus h square. Well, for the denominator, probably we can no longer simplify that. For the numerator, it is only 2hh minus h square left. Well, probably we cannot carry out any simplification, and therefore let's leave it here. Okay, so this is the end.